So if you're a class 11 student and you're preparing for NEET examination or JEE mains, you will find this topic of electron affinity to be very important and useful. So I've tried to cover some aspects of electron affinity. And then in my next video, which will come, I will discuss the exceptions which you see in the behavior of electron affinity, especially in the halogen group. In this video, we will cover the characteristics which are exhibited by different elements, different blocks in when it comes to electron affinity. And I have also covered a reason why the particular element behaves in that manner. So hopefully you'll find it useful. And let's start the video now. Thank you very much. Morning. So today we will study the topic of electron affinity. It is a very important of uh, chapter of class 11 periodic properties from where it is taken. So let's discuss electronic affinity, and we will start with the first thing, which is the definition itself. So if you can see, electron affinity is energy. It's measured by the units of energy, kilojoules per mole, and is applicable only to the neutral atoms of in the gaseous phase. So you cannot have electron affinity for studied for a metal. Okay, and when does it come in picture is when an electron is being added to an atom in an electron to form a negative ion. Now this is very important. Whenever you study the chapter of periodic properties, especially this electron affinity, this is not to be studied when you're removing an electron. This is studied when the electron is getting added. Let's look into the definition again. It is the change in energy of a neutral atom in gaseous phase when an electron is added to the atom. Right? Now, what does it result in? It results in formation of a negative ion. So you know what is an anion. So whenever you're studying electron affinity, you're creating anions. Okay. The short definition, and it does not include any energy, is that it's a likelihood of gaining the electron. Okay, it's a likelihood. It's a okay, but the real definition, which you must write in your school, has to mention that it is a change in energy of a neutral atom when an electron is added to that atom. So an atom is available, you give energy to it, the energy of the atom changes. That change in energy of an atom on per mole basis is called as the electron affinity. Lot of people remember the definition which I've written below as the short definition, which is the likelihood of gaining electron. Now that likelihood sounds more like a layman way of explaining the definition of electron affinity, that yes, you want to gain an electron. It is a tendency. There is a likelihood, but in reality, the strict definition has to do with energy. It has nothing to do with the likelihood. That's a very non-scientific way of explaining. It is correct, but it's not scientific. You will not get any marks if you write the short definition, but if you write the full definition in your school examination or wherever you are going to get full marks, right? So always write the change in energy of the neutral atom when an electron is given to it. Remember, gaseous phase. Let's talk about the next slide. Now we have talked about energy now, right? Energy of the, that per mole or the atom, if it's a single atom, changes when it gains the electron. Now we must know what is this change happening. Is it about gaining energy or is it about losing energy? Okay, that is very, very important for us to understand. If you see this slide, you can see there are two types of reaction. Before we go to the concept of change in energy in electron affinity, let's understand there are two types of energy changes that happen. Number one energy change, which is very important to understand, is the exothermic reaction, in which the system, right, is losing energy. I'm the atom, you do something to me, and I lose energy, which means this reaction where the system loses, system means a group of atoms, they lose energy. You will say this reaction or this happening is exothermic, and the sign you will attach with the change in energy is negative because the system has lost energy. So you will see change in energy from system's point of view. I am the system, I am 1 mole of atom, I have lost energy, and therefore the loss of energy will be labeled as negative. Let's go to the second one. However, if the system gains energy, right, instead of losing it, then that reaction or that change results in energy being added to the system, and therefore the sign given to that energy change is called as endothermic. It's an endothermic reaction, and the sign given to it is the positive sign, which means the system has gained energy and says the overall change is positive. So these reactions are called as endothermic. The one we studied previously is called as exothermic. So please remember the concept of electron affinity is just not the tendency to gain or lose electron. It has a lot of association with the energy change of the system, which is used to explain it. Let's move to the next slide now. All right. Now if you notice, okay, and we will now focus on what happens in the situation of electron affinity, where the system takes an electron, changes the energy, but the question is how this energy changes. Does it result in an exothermic reaction, which means the atoms in the gaseous state who gain the energy lose energy, or do they gain energy and it results in an endothermic reaction? We will have to study this in this upcoming slide, and you will be up for a surprise. It will surprise you. The first thing is, if you pick up a neutral atom, that neutral atom, when it gains the electron, right, at that point of time, it will demonstrate that the system has lost energy. So now we are referring to what is called as the first electron affinity, which means the system has taken the first electron. Okay, if it's a mole of atoms, they have taken a mole of electrons and now become anions. Due to this, the system will lose energy, and therefore the electron affinity, the first electron affinity, is going to be negative because the system has lost energy. Got it? You can read that. Now the system has become an anion. It is already negative. Now let's study what happens when we try to add one more electron to this system. It already has acquired one electron. It has become a negative ion, which is an ion, and now you are sending one more electron to be added to this atom. The moment you try to add an electron to this atom, which is already negative because of the first electron you have already added, it will not be an easy task. It is very difficult to add an electron to some atom which is already negative and an anion. Now which means the anion will repel the electron which is coming in. The electron wants to come, the second electron, but now the anion, which is negatively charged because of the first electron, will repel it. This means Now you will have to provide energy to force this electron on this anion and give it a second electron. This means if you give energy, you will have to do work. That work will get stored in the form of energy, and therefore the second phase of the situation where you're adding the second electron is endothermic. You have added energy because you have to apply a lot of force to add the second charge. Conclusion: when you add first electron and make the ion, the system loses energy. The sign of the change in energy, the electron affinity is negative. But the second time, when you add the second electron, the system gains energy, and therefore the sign is positive. So adding second electron is endothermic, adding the first electron was exothermic. And therefore you should be cautious in the question. When you're doing the question, see very carefully the electron number is what. If it's a first one, the sign of the energy, electron affinity, is negative. In the second case, it is. I hope this is clear to you. Let's talk about one more important confusion in the minds of the student. Ionization energy versus the electron affinity. Now, ionization energy, which you must have read, is concerned with removal of electrons, and therefore it always results in formation of positive ions. However, the electron affinity is always concerned with the creation of negative ions. This should be clear in your head, that what is the aim of using the ionization energy, what is the aim of electron affinity energy. Entirely different. One results in the creation of negative ions. We just studied it before this slide. Ionization energy, I will bring up a video to explain you everything about ionization energy. I hope this distinction helps you. It can be a one marker in your school. And also, this brings a lot of concept clarity for student. Alright, so let's study the electron affinity down the group. Now, in your school examination, one of the very important things you have to study and explain in your question paper is what happens to the electron affinity as a property exhibited in periodic table in group number 1. It is very important to understand group number 1 because it will give you a more better balanced view of the concept of electron affinity. If you notice, the electron affinity in the case of lithium and then sodium, then potassium and rubidium is negative, it is, but the value of these energies is very small. Alright, so if you add one electron to the metal, the ion you get is very unstable. That is because the electron has very few valence electrons, and adding more and more electrons does not help to achieve stability, which comes from the octet. And therefore you see the values of electron affinity, which is negative, to be very small, which means the metals resist accepting electrons. All right, we will do a detailed deep dive into why this behavior. One behavior obviously is because of the low valence electrons in the metal. The second important thing which you must know is the behavior of electron affinity of non-metals. And to me, this is the most important thing that you need to study, which is non-metals. Specifically, I will say halogens. I will bring out the next video on the halogen group, which is very important for you to study for the purposes of electron affinity. If you look at non-metals, what happens there? You already have quite a lot of valence electrons if you give one or two electrons to them, the shell gets complete, right? And also note that these have higher effective nuclear charges, right? So please understand the concept of effective nuclear charge. If you're studying this chapter and you don't understand effective nuclear charge, it is very hard for you to understand it. Look into this concept very carefully. Coming back to electron affinity of nonmetals. Non-metals, as you can see, have very large number of valence electrons, and if they accept one or two electrons, they will acquire a lot of stability. And therefore, if you see the value of electron affinity energy measured in kilojoules per mole, you will realize that the non-metals are exhibiting very high values of electron affinity measured in kilojoules per mole on the negative side, obviously. So they become very, very stable. When they create an anion by accepting the first electron, they acquire a lot of stability, right? So compared to a metal, the non-metals have very high degree of electron affinity. Okay. Now let's talk about the halogen series. I will prepare a separate video because this has some exceptions which are going to be part of your examination in school. You will be asked a question on this. Now, if you notice fluorine, chlorine, bromine, and iodine, chlorine is exceptional actually, right? Chlorine of all has the highest electron affinity. And there is a reason why chlorine even has higher electron affinity than fluorine. This question is a very important question for you to do. Why the affinity of chlorine is higher than that of fluorine? This abnormal behavior has to be understood. All right. And as you can see, we are going down the group, and as we are going down the group, the electron affinity is decreasing. You can see that at the top of the group, which is the halogen group, the value of negative energy is highest, which means fluorine has highest electron affinity, and then suddenly chlorine shows an abnormal, further increase of the electron affinity, which is abnormal. It should not have, because as you go down the group, your electron affinity, you can see, is lowest for iodine as compared to fluorine. So fluorine to iodine, as you go down the group, you expected it to go down. We will talk about why, but suddenly you have an introduction of chlorine which causes this abnormality. Remember, chlorine is something you have to focus on and understand why this abnormal high levels of electron affinity on the negative side. Let's move forward on this. Now, we understand that in a group, as you go down, the electron affinity decreases. When I say decreases, it is moving towards zero. If I say minus 500, I am saying my electron affinity is very high. If I'm saying minus 200, I'm saying my electron affinity is low. So when you talk about a group, if you move from the bottom of the group to the top of the group, you will find that the attraction to accept the electron is more. At the bottom of the group, there is a resistance to accept the electron comparatively, but at the top of the group, the electron acceptance is very high. Let's talk about now the behavior of electron affinity rightwards in a period. We already understand when we talk about the S block elements like metals, which are alkali and alkaline earth metals, they are not willing to gain an electron because nothing stable comes out of that behavior. However, as you move towards the right hand side, the when you reach the group number 17, which is a halogen group, you realize that the values of the electron affinity are very high. When I say very high, I mean negative very high. because they become very, very stable. Also, if you read the reasons which are mentioned here, right, you can see that when the electron is being added to the energy level, which is closer to the nucleus, there is a very strong attraction between the nucleus and the electron. But if you're adding the electron on the outer shells, right, where the effect of the nucleus becomes less, but remember, across a period, if you notice, the Z effective, which is the effective nuclear charge, felt by the electrons, which is the electron of interest, the outer electrons, the core electrons provide the shielding, and the outer electrons face less attraction from the nucleus. So it is very easy for you to add the electron when you are in moving across a period on the right hand side, because now the charge, the effective charge has become very, very powerful. Although you're entering the same orbit number, yet the electron is getting added because the effective positive charge is high, and as soon as you add the electron, it shows up in the form of increased electron affinity. That means the attraction to add the electron increases from left to right. And you already have examples of metals on the left and halogens on the right. I hope this helped you. So remember the keyword effective nuclear charge is very, very important factor in deciding an increasing trend or a decreasing trend. You will be given questions in the examination where you will have ions, or you will be given some neutral atoms where they will ask you arrange them in increasing or decreasing order. Please notice very carefully whether it's across a period or going down the group or up the group, and then decide your answer accordingly. Alright, this is a very, very important graph for you to understand. As you can see in this graph, some of the elements exhibit a positive value of the electron affinity. Okay, and most, if you see, like sodium, like aluminium, right, where you see, and I will just mark them for you, all right, so that you can understand where I'm coming from, are exhibiting a type of behavior which is different, right? So you can see the behavior. This is your neon, right? Neon, and then look at this particular behavior, so negative. I told you chlorine is the king. Chlorine has the highest electron affinity. The most tendency to accept an electron comes from chlorine, surprisingly, right? And this is an exception in that particular group, because in that particular group, the electron affinity of the halogens would have gone down. Not in the case of chlorine, it increases. Very important, right? Now let's also look at others, right? So look at the electron affinity of halogen group, right? All of this is halogen. So the maxima of electron affinity is seen at the halogen group, and that is why this is of tremendous interest. Also notice the minimas which are coming here. Okay, I'm just marking the minimas which are coming, and as you can see, these minimas are coming at the bottom of the group at the noble gas, right? And this is a surprise, because as you're moving rightwards, you realize the electro affinity is increasing. But the moment you reach the right extreme, which is your inert gases, this is what you find. The suddenly, abruptly, the trend breaks, because noble gases do not want to accept the electron, because they already have a completed octet. A lot of this discussion is around the completion of octet, right? So remember that. You must have studied this in the previous classes also. So you must be able to read this graph very carefully, remember the maximas, see the behavior, and also understand how the metals are behaving. Look at the metals in this whole chart. hovering around very low values, right? Very low values of negative. And then, of course, some of them even exhibit a positive value. Barium, for example, is exhibiting a positive. No, barium is not. Barium is still negative. But if you look into cadmium, right? Cadmium is still exhibiting a behavior which is a positive electron affinity, right? So I hope this helps you. This one, right? And let's talk about other ones also. Look at zero electron affinity, right? This is also very interesting, right? Close to zero, you have manganese, Sr, and then you have hafnium. These are zero. Exhibition of zero energy change if the electron gets added, right? So you must know these interesting parts of the discussion and try to reason out why. Essentially, the understanding of effective nuclear charge and the size of the atom will help you understand this concept in a better manner. Once I bring the difference between the chlorine and fluorine, what's happening in the halogen group, it will give you a detailed analysis of what's happening. But for the time being, just have a look at this and try to understand what is in front of you, right? So in your examination, you can expect graphs that come, and based on the graph, you will be asked certain questions. Summary of what we did today. So electron affinity is liking for electrons, but this is not the scientific definition. You have to complete this by saying the energy associated with the addition of an electron is the real definition in kilojoules per mole. Now this energy which is associated with the addition of electron, if it is positive, then you're saying that the electron is not going to get added because addition of electron is accompanied by adding energy to the system, making it unstable. Example, metals. What you want is whenever the energy is associated with addition of the electron, the value should be more and more negative. The more negative it is, better it is. Okay? And then if you go down the group, which is a family having same number of valence electrons, you can see the electron affinity decreases, right? And if you go upwards, it increases, right? So this should be clear in your mind. And last thing we've already discussed, but as a summary, across a period from left to right also, you must understand it is going to, if you move from left towards right, you will find the electron affinity going up. Take fluorine and chlorine in your mind to be the ones that have the highest electron affinity. Anything close to that will exhibit similar properties. But there are situations which are not in line with what we have studied. Very few. For example, chlorine is an exception that you must be aware of. So I hope this helps you understand the concept of electron affinity and also gives you how to write all of this in examination. The keywords in your mind have to be effective nuclear charge, the electron repulsion, the shielding effect, the size of the radius, and energy released during this process of first electron affinity. The behavior of second electron affinity was very different because the value of energy was coming out to be positive. Thank you very much. Watch this video again and you can give me your comments below if you want more videos like this. Thank you very much.